Hello, and thank you for joining. My name is Yuval Shchori. I'm the head of product management for everything cloud security with Checkpoint. And today I'd like to talk with you about how to leverage machine learning and AI to effectively shift left. And of course, I'm talking from a security perspective. So before we delve into the details, let's look at what really keeps security people awake at night. First thing is visibility. One of the challenges with things being done outside of the traditional organizational structure, outside of the traditional perimeters, we like to call it within security and networking, is visibility. We don't know from a security perspective what's being built. We're not sure how it's being built. It's very not how it used to be back in the days 20 years ago when there were always like 3-layer applications. It was always in our data center, et cetera, et cetera. Which kind of leads to the next thing is, how do security people keep themselves relevant where a lot of the decisions, because it's in shift left, right? A lot of the decisions are shifted left. A lot of the decisions are made by DevOps engineers and developers. And how do they keep supporting the business and the business growth and the business agility and velocity, but still provide what they need at the right time? Next is complexity. The amount of different cogwheels that now work together. Again, think about what used to happen back in the three-tier application world. The amount of terms that we need to remember. What's a pod? What's a Kubernetes service? What is a serverless function? What's the difference between a VM here and a VM there, et cetera, et cetera? Things have become very, very, very complex for security people. Last but not least, and this actually never changed, is how do I keep myself off the Wall Street Journal, right? How do I make sure that I'm not becoming a headline in the Wall Street Journal, especially when all the rest of the complexities happen, right? How do I make sure that the decisions that are shifted left and made by developers and DevOps, which are not security people per se, how do I make sure it does not expose the organization and I could be a target for an attack? And that's exactly where the machines and machine learning comes into the rescue. First and foremost, machines can actually take the plethora of information that's currently coming from the cloud and make it into actionable insights, provide the visibility for the security people to actually act upon, and not just, hey, just so you know something's happening, but something is happening. And because we're using machine learning models, actually this is what you should do in order to prevent this thing that happens from becoming a real threat. This is how you reduce the attack surface, et cetera, et cetera. Next is the fact that unlike traditional security system where you say, listen, I don't want to log everything, because if I log everything, I need someone to go through the logs and see what's relevant and what's not, or maybe audit. When you have a machine that looks into the details, you don't need to think about this. And actually, we all know from how machine learning models work, we understand that the more data we feed the machine learning systems, the more accurate the results are, back to actionable insights. And you want to really use like the minimal effective dose of actions to make sure that you reduce as much as possible the attack surface. Last but not least, we need to remember that it's a new world problem. Everything that we know from the good old on-prem world is not always relevant, especially where you're taking things and you're cutting them. And I think that Kubernetes containers is a great way to look at, well, I don't really have like an entire operating system wherever I go. I just have those containers. Right? Which means that I need to maybe focus less on things that come from the operating system. Maybe I need to get even more into the application side, right? And we need to remember that from an application side, the app is kind of the cherry at the top of everything. This is what we need to secure. Of course, we need to secure everything, but if we secure the storage and we are not securing we're not securing the ability of an end user to access the application and through it to storage, we didn't really do what we need to do, right? So because it's a new world problem, we need to understand we also need a new world solution, and that's exactly what I want to demonstrate today. And maybe I'm not going to just demonstrate a product. I'm actually going to look at something that happens around us. And I'm sure that, in the world, there are hundreds of organizations today that have a meeting where a security person sits with a DevOps engineer and say, okay, tell me what network security policy does the application need in order to operate? And not always the people that write the application or actually put it into operation know exactly what's the security policy that's required. In traditional days, what's happening is that we're taking an Excel, we start importing logs from all sorts of firewalls or switches or routers that look at the traffic. Here it's a little bit different because, for example, in a containerized environment, it's almost like a black box that not always you understand what happens in between different pods. So let's look, what do we do in order to ensure that not only we're capable of deriving the security policy, but also support changes in scalability and everything that happens within a containerized environment as we move forward, without just relying on asking the DevOps and the developers questions, but instead looking at what really, really happens. So how do we harness the AI capabilities in order to create a Kubernetes access control policy? Let's see. And what we see here is, a containerized application with a front end, some services, a back end that takes care of everything, and of course a financial system that is more secure from everything else, because we want to make sure that no one can get there. But what different type of traffic goes there, right? This is exactly why we need a discovery model in order to understand what's happening inside. And the discovery model is a Helm chart. We're going to install it on our containerized environment. It is going to perform like an initial discovery of different pods, different services within the system. But as you can see, it's very limited. It actually just described a single zone of traffic. It doesn't yet understand exactly the different zone. And this is where we start learning the traffic, right? We are learning the traffic in order to suggest an access policy for this zone. And what we need to remember is that there are things that you can start preventing on day one. You don't need to learn, right? If you want to prevent access to malicious domains or to command and control centers, you can do it from day one, but it's not really what we want to focus on. We want to focus on the ability to learn the different vectors, the different traffic patterns that happen, the different transactions that happen. And what you could see that, for example, after 1 hour of the system operating, there are some suggestions like, yeah, these are the generic rules that we think you need, but the system at the same time says, well, you need to keep learning, right? And after it ended, it learned for hours, it actually provides an entire set of different zones. And if you take a look at these vectors, you can actually see that it looks very much like, again, from a functional perspective, it looks very much like what you see on the diagram itself. It suggests a security policy. The security policy is based on containerized attributes and not IP addresses or something that might change. And we are ready to go. So think about everything that we saw, from understanding what type of traffic, suggesting policy, and actually seeing traffic that's being accepted or denied based on this access policy, all through a machine learning system. Now let's look at another situation. Something that happens quite a lot of times where a serverless function, for example, is being built, and the security engineer is trying to understand how could they reduce the attack surface by limiting the permissions that are allotted or assigned to a serverless function. And some of the times the DevOps or the dev engineer are going to say, well, I don't really know. We're using a third-party function, or we're using a library that we got from somewhere else, and it comes pre-configured. We don't know what are the different vectors that are required, different permission models, and it's almost impossible for a security engineer to really secure such a serverless function. And that's exactly where we could harness and use AI in order to reduce the attack surface. What you see here is the results of using machine learning capability through static code analysis and additional mechanisms that looked at the serverless function and mapped everything that it's doing, mapped all the resources it uses, but it did not stop there. It also looked at what permission models are needed per resource in order to understand what is a must for the resource to be configured from a permission perspective versus what is actually configured. And the discrepancy between what is required and what is configured actually provides the delta model that says, well, here you have like a critical asset to which you provide, everything, every operation is allowed to every resource, but it's not actually what you need. We don't stop there, because what we could also do is actually provide a suggested policy. The suggested policy actually shows what is the required set of permission that we learned about. And by doing so, not only we reduce the attack surface, we're actually allowing the security person to speak the lingo of the DevOps engineer or the DevOps or the developer engineer by delivering a YAML snippet or something that they could automatically remediate the challenge they currently have and actually talk the same language with them. So let's summarize. First, we understand that data does not provide visibility, insights do, and we need to remember that there's a difference between just pushing a lot of data towards the security peeps and pushing something that is insightful. And that's exactly where machine learning can actually take the giganormous amount of data and make it something that is worthy of consumption by actual people, right? Crunching the data and getting something from there. And it's exactly where we should focus on using AI and using ML in order to maximize our capability in the security space. When we need to find a million needles in a giant wheat field, that's exactly where we could maximize the machine in order to understand what is happening. Thank you very much.